All right, so you're a Cisco shop and you're making the move into Google Cloud. You've hit a really critical question. How do you build that connection? And I don't mean just a temporary bridge, but a permanent, rock-solid, production-grade link. That's exactly what we're going to break down today, the definitive blueprint for a truly resilient hybrid network. First things first, let's get one thing straight. Hybrid cloud isn't just a phase we're going through. For pretty much every large enterprise out there, it is the permanent operating model. It's the new normal. And that means getting this network architecture right from day one isn't just some quick fix. It's a foundational, long-term strategic decision. Now, before we start building, we have to bust a really common myth. I call it the layer 2 illusion. All those traditional networking habits you have on-prem, like stretching a VLAN into the cloud, they just won't work here. Google's network is a pure layer 3 world. That means it totally ignores VLAN tags, drops broadcast traffic, and all the old tricks for failover like gratuitous ARP. Yeah, those are complete non-starters. This is the big constraint we absolutely have to design around. Okay, so knowing that layer 3 is our only path forward, we find ourselves at a crossroads. When you boil it all down, there are really 3 architecturally sound ways to build this hybrid connection. So let's dive in and look at the trade-offs for each one. So on one side, you've got Google's native HA VPN. It's simple, it's fully managed, and it comes with a great SLA. Sounds good, right? Well, the downside is it's basically a black box. You lose all that rich Cisco functionality like application-aware routing and that deep visibility you're used to. On the other side, you've got the Cisco C8000V, a virtual appliance that brings the full, powerful iOS XE feature set that you already know and love right into the cloud. Then you have the other end of the spectrum, option C, Google Cloud VMware Engine, or GCVE. Now, this is the one and only way to get true Layer 2 extension into the cloud, which lets you do things like vMotion workloads without changing a single IP address. But, and this is a big but, this comes with a massive price tag and a ton of operational complexity. You're essentially running a whole parallel network stack with NSXT. This table really lays it all out, doesn't it? If you look at the cost row, the native VPN is obviously the cheapest, and GCVE is way, way more expensive. The C8000V sits right there in the middle. But now, look at the Cisco MGMT row. The C8000V is the only option that says yes. It's the one path that lets your network team keep using their existing tools and expertise. For most Cisco shops, this makes it the clear sweet spot. Okay, so we've made our choice. We're going with the C8000V. Let's get into the weeds of the recommended architecture. Deploying the Cisco C8000V and integrating it with Google's Network Connectivity Center. This, my friends, is where the magic really happens. So here's the most crucial point to understand. The C8000V is, at the end of the day, just a virtual machine running in Google's cloud. It can't magically tell Google's network fabric about all your on-premises routes. Just pointing static routes at the VM's interface is brittle, it doesn't scale, and it's a recipe for an outage. For a dynamic, production-ready solution, you must use the Network Connectivity Center, or NCC. And this shows just how brilliantly it works. The whole process might sound complicated, but it really just boils down to 4 simple steps. First, you tell NCC that your C8000V instance is a special router appliance. Then, you set up a standard BGP peering session between the C8000V and Google's Cloud Router. Third, Cloud Router automatically takes all the routes it learns from your C8000V and injects them into the VPC routing table. And that's it. You've got a dynamic, bidirectional exchange of routes. Okay, so we have a working connection. That's great. But working is not the same thing as production ready. Not even close. Now we need to harden this architecture. Let's talk about what can go wrong and how we build in resilience right from the very start. Let's tackle the most obvious and, frankly, the most terrifying risk. A single C8000V instance is a single point of failure. If that VM goes down for any reason, a host failure, a zone outage, a software crash, your entire link to the cloud is just gone. That's just not acceptable in production. The solution is a classic high availability pattern, and it works beautifully. You deploy 2 C8000V instances in different availability zones for redundancy. Then, you put a Google Cloud internal load balancer in front of them to health check both and direct traffic. And for the routing control plane, you use BFD, that's bidirectional forwarding detection, to get sub-second failover between your BGP sessions. If one router goes down, the other one takes over almost instantly. All right, here's another silent killer of performance: MTU issues. The IPsec and GRE encapsulation you're using adds overhead to every single packet. If you're not careful, you'll end up with IP fragmentation, which absolutely destroys throughput for critical things like database replication or big file transfers. And here are the exact settings you need to fix it. You need to configure TCP MSS clamping on the tunnel interface, and you're going to set it to 1360. This basically tells servers on both sides to send slightly smaller packets to make room for that tunnel overhead. You also have to make sure your firewalls aren't blocking the ICMP messages needed for path MTU discovery. Trust me, these small tweaks make a massive difference in real-world performance. So we've covered a lot of the tech, but let's be real. A successful hybrid cloud is as much about people and process as it is about packets and protocols. So let's zoom out for a minute and look at the organizational side of things. This architecture sits right at the seam between your traditional network team and your new cloud platform team. You absolutely must define who owns what. The network team owns the Cisco box, the iOS XE config, the routing, the tunnels. The cloud team owns the GCP infrastructure, the VM instances, the VPC, and IAM. And they both share responsibility for things like monitoring and incident response. Without this clarity, you're just setting yourself up for failure. Look, let me be very blunt here. Manually clicking through the GCP console to deploy this kind of critical infrastructure is a recipe for disaster. This entire setup, the VPCs, the C8000V instances, the NCC configuration, all the firewall rules, it all must be defined as code, preferably in Terraform. It is the only way to make sure it's repeatable, reliable, and auditable. It's non-negotiable. So what's the big payoff for all this work? Well, it's pretty significant. For any organization with a lot of branch offices, this architecture gets rid of the need to hairpin cloud-bound traffic all the way back through a central data center. And what that does is directly reduce application latency for your cloud workloads by a staggering 40 to 60%. That's a number you can absolutely take to your leadership. And that brings us right back to where we started. This isn't about some temporary fix. The real key takeaway here is that the hybrid model is permanent. And your network architecture has to reflect that permanence. It has to be built to last. So the final question to leave you with is a simple one to ask, but a pretty complex one to answer. You know your cloud is going to be hybrid forever. The real question is your network truly built to last?